Hey everyone, welcome to the Tom's Hardware Podcast for January 18th, 2022. As always, I'm Tom's Hardware Editor-in-Chief, Avram Pilch. I'm joined by Associate Editor Les Pounder, Raspberry Pi expert Ash Hill, and our very special guest, James Adams of the Raspberry Pi Foundation, who has worked on designing the Raspberry Pi boards since Pi 2. Is that correct?
Ooh, no, earlier than that. Hello, everybody. So I joined Raspberry Pi back in 2013, so beginning of 2013, along with another gentleman you probably heard of, Gordon Hollingworth. So this was when Eben and the first Eben and the first five guys had got the first Pi booted up, if you like, and there was some money coming in, so it needed a proper company formed to sort of take it forward. So I joined with Gordon. We were the first two employees of what's called Raspberry Pi Trading, or now just Raspberry Pi Limited. And we work for the tech company, effectively the tech company side of Raspberry Pi. So we design all of the hardware, do the software. So right at the beginning, it was Gordon and I and Starbucks. So we didn't have an office, and we sort of built it up with Eben and sort of from there. So I'm sitting in the trading office. We actually have two offices now, separate from the foundation, just because we sort of have different sort of goals, I guess. You know, the tech company, we have a lab with a whole bunch of equipment. We have lots of secret stuff, and those guys are doing more, doing all the educational stuff, and they need to get people in and have all the sort of workspaces for people and stuff. So, but we're still in Cambridge, not too far away. But as we've grown, we've just sort of changed a little bit, I guess, growing as we've done.
Wow, fantastic! So, you actually have some early prototypes on your desk, correct?
I do. I did look for a B+ prototype. So that was the first. Hang on a minute. So I have this is the original. Well, this isn't the very original. This is the second version of the original Pi that Pete Lomas designed. And B+ was the first, what I call the new form factor, right? So unfortunately, because I think the box it's in, I think it's probably in my garage somewhere. I can't find it. But the new form factor, and this is a Pi 2. This is a Pi 2. The new form factor is, the four mounting holes and the rounded corners and the bigger, bigger header and the sort of the connectors on the sort of two sides rather than all the way around the board. So I put together the B+ and the Pi 2 and the Pi 3, and I sort of had a break at Pi 3 B+. It's sort of an evolutionary incremental product, and then I came back and did Pi 4. When I say did, I mean these things are a team effort, but I've sat at the top and driven a lot of the design decisions and the CAD layout, I guess. So yeah, Pi 4, I did the CAD layout. So I'm sort of keeper of the form factor, if you like, in a way. But of course, there's a big team effort to design the silicon and all the testing and the software and the production test as well, which is a huge part of why why we're able to produce these boards in large volume for not much money.
James, why was there a change in the form factor from the original Pi to what we have now?
It's a good question. So the very original Pi didn't have any holes at all, and I think people, spotted that straight away and said, "Hey, we want some holes." This one, which has some holes, actually those aren't really mounting holes. They're what we call tooling holes, and what they do is when you have a test jig to put the board in, you need some kind of locator, right, so that you can press it into the jig and connect it. So that's kind of where these came from. So they dual role as a sort of a mounting hole for the test jig, but also holes for putting screws in. And they just happened to Pete found some space where you could drill some holes through the board. Really, that's kind of how they came about. So when I came along, I was just keen to sort of obviously they're useful. Obviously, it's useful to have them on the outside of the board. So because Pete's tools were different to the ones that we were going to use at Pi and what I was historically used to using, these designs basically were sort of a clean sheet, although we pretty had a good idea of what things we were going to put on it. And so just playing around with the layout, the 4 mounting holes came out nicely with the connectors at the side. And immediately I sort of saw that. I thought, it would be great to have a hardware. It sort of outlines the hat form factor. So that was when that idea came together. And the rest is history. It sort of worked out as a very nice form factor. One of the other things I was pretty keen on doing was pushing the ports as far to the edge as possible.
Yeah.
Because even at that time, we kind of knew that we wanted to have a line of products. And actually, the more space you make in the middle of the PCB for different chips and different, just space for the layout, right? The more likely is you're not going to change your form factor from product to product, right? So we were kind of hoping we had plans to have a Pi 2 and then maybe future things, and that kind of worked out well. We didn't really have to change the form factor from B plus to Pi 2 to Pi 3 very much at all. And really, even Pi 4, I mean, it's a bit different with Pi 4, and we can talk about that. But that actually worked out, that worked out really well.
That's cool.
So
the hat standard that you've got now, that came out in July 2014, something like that, I think it was.
It's a good question. Yeah, yes, B plus. I can't remember the exact launch date, but it was 2014. Yeah.
So the question to ask you was 2 questions. What is the hat standard, and why did you go from 26 GPIO pins to 40?
That's a good question. I think, why did we want more? Because, okay. So the 2835, it was back in B plus days. That's what we use on Zero still. That chip has Gpio on it, and it has separate banks of Gpio. Each different bank you can run at different voltages if you want. And basically, we could dedicate an entire bank of 28 Gpio to the connector. So really the question was, how can we get all of those out? Because actually it's useful to have them all, because some of the interfaces like parallel RGB, or they call DPI interface, can use all the pins, and we could see how useful pins were to people. And a 40-way header kind of neatly fitted between those 4 mounting holes, so it all just sort of came together, right? It's like, how many pins can we add? Oh, 40. Oh, that all works nicely. Oh, we've got all of this whole bank. Can we squeeze the whole bank on? And so actually, when I was doing that design work, there was a big, robust discussion about whether we should actually change the pinout of the, because currently you've got your 26-way one on the original Pi, and then we just extended it to the 40-way, right? So the 26 pins are still the same on the 40-way. So you can kind of the old Pi hats can fit on the new Pis. But there was a big discussion had as to whether we should radically change it. So the 40-pin header could have all the GPIOs in a line and all the grounds in a neat place. And I think, the one-side one to keep the compatibility, which isn't necessarily a bad decision. I mean, it's a decision. And so that's why the GPIOs are all a little bit scrambled and the grounds are in funny places. It was to keep the compatibility. But actually, it works for everyone and it's fine. I guess, would I go back and make a different decision? I don't know. It's a decision made at the time, and it worked for everyone, so I think it's fine. It kind of always irks me a little bit because I get OCD about these sort of things, that the pins aren't all in a nice line. But there we are.
Understandable.
I have a question about the Pi 4 and the choice to go with micro HDMI ports.
Yeah, I knew that was going to come.
So was there a time at which you tried to fit regular HDMI ports on the board and it didn't work? Did you consider mini HDMI? How did you come to that decision?
Yeah, so Les has got a picture, haven't you?
I have indeed.
Got the Pi 4 prototype in there. We go. Look, I'll use mine here. So this is this is the very first prototype of Pi 4, and it has indeed got a big HDMI and a micro HDMI, as you can see, and it also doesn't have USB-C. Oops, wrong side. There we are. This is just a normal USB-B. So yeah, again, this is another one that took a while to resolve. The big HDMI takes up a lot of board space, and I guess the long and short of it was, we got to a point that we were pretty confident we could make the micro HDMI work, And if you look at the difference in the kind of, I don't know if it's going to be very clear on the video, if you look at the difference in the space that the micros take up, I mean, they're much more space efficient. And another issue is if you look on the back, which you may not be able to see very well, but if you look on the back, to string the HDMI to the other connector, there's a lot of wiring there that has to go all the way across the board. So it's not a particularly nice layout for this guy. Whereas with the Pi 4, you can just bring the wires kind of right down. I can't do it backwards. Right down to the connectors. So yeah, we kind of got comfortable with micro HDMI, and we did a lot of work actually with the connector manufacturers to change the connectors. Again, I don't know if you can see very well, but if you look at these micro HDMI, you'll see there's like a little flare on the end. Now that isn't, that was one of the edits we made to the connector so that you can actually insert the thing more easily. Also that, primarily that was for automated test because we build all our Pis by robots. We needed the connectors to be able to go in the connectors easily. And those little flares kind of really help with that. But also we changed the pin length, we changed the sort of insertion pressure by twiddling the sort of insides, and we just got comfortable with these micro HDMIs, and it just sort of, it's the right answer. Again, if you're going back to the how much we need all the space we can get in the middle, making the HDMIs smaller was kind of a big win, and I think it just looks better as well. And touch wood, to date, we really don't get any, apart from people who don't like it because it's micro HDMI and you need an adapter or you need a different cable. We've never had any kind of robustness issues. We don't see people breaking these, which is, we thought we would get a little bit more of that actually, because for sure the bigger connectors are stronger. But actually, it's been very surprising that we don't see any issues with these, mechanical, robustness issues with these at all, actually. And we bought ourselves this nice extra space in the PCB for future products, I guess.
I have a question there about the Pi 4. Well, not just the Pi 4, I guess any of the boards that you've had a chance to work on, but are there any modules or components that you wanted to see make their way to the final board that for whatever reason weren't able to make it to the final design?
Oh, yeah, that's a good question. I'm just trying to think of the best way to answer that. I mean, we go through a lot of options when we design these things, and a lot of it comes down to price. So we kind of know what the form factor is going to look like. We kind of know the port configuration. So obviously Pi 4, we knew we were going to have 2 HDMI, and that was a big thing because we needed to figure out what arrangement those would be. And I guess Pi 4 was an interesting one because we had this chip that had a PCI Express interface. It wasn't completely clear what to do with that, right? Whether it ended up that we have a bridge on there that will do PCI Express to USB 3. But it wasn't clear. It wasn't completely clear at the time that was the right answer, right? It could have been that we would expose that PCI Express connector, interface on some different kind of connector or something. So it kind of was driven by the price of the product. So we ended up finding a well-priced PCI Express bridge, and it fitted on the board, and it worked really well. So in the end, that's what drove the decision. I think that was definitely the preference for building that product. But you could have had a Pi 4 with an M.2 or something on it. That would have its own design challenges, of course, because of power and because actually the PCI Express interface on the 2711 chip has a few quirks. So not every single PCI Express card would work with it. But that's the kind of design decisions we go through, and usually the sort of product cycle for these is pretty long now, right? It takes quite a few years to get one from initial kickoff, which is kind of thinking of what chips are we going to use, what manufacturers are we going to use, and talking to people like Broadcom, who we sort of co-design with them, I guess. We talk to them about what features we want, what chips, what are they working on, what technology can they bring to our chip, and what custom bits can they do for us, and what what's the price, and all the rest of it. And that takes quite a bit of time. So it's sort of, there's quite a long period where we can change things. Having said that, because these products are all quite incremental, deliberately so, it's usually pretty well understood what we're going to do next. So I think it would be really nice to have some kind of PCI Express on a Pi, actually, because it's a great interface and you could plug cool stuff into it. However, it's not the right interface for Pi 4, and that's, I'm kind of happy with where that product ended up, actually. Hope that kind of goes some way to answering the question.
Yeah, definitely. I think the community likes the PCIe too, because we saw people play with that as soon as the Compute Module 4 came out. The carrier board that Sterling worked on and things like that.
We knew people who really wanted to use it could have a go with CM4. So USB 3 is more generically useful. So I'm pleased we ended up building it that way.
So we have some questions from the chat room. Martin asked, what was the biggest challenge of the layout design of Pi 4?
Okay. It's just quite tight. So we use relatively low-tech PCB technology for these boards. I mean, this is relative, right? Relative to something like a mobile phone. It's a 6-layer PCB, and it's got what they call HDI technology. So it's got laser vias. So you can connect the top layer to the next layer down with some teeny tiny vias, and you can put those in the pads of the BJs. And it has what they call blind vias, which is vias that are inside the board that go from layer 2 to layer 5. But other than that, it's kind of fairly standard. So that's 6 layers is not a lot of layers when you've got DDR interfaces and 2 HDMI connectors and all the rest of it. So if you look at these boards these days, there's quite a lot of componentry on this. But we've engineered with Broadcom the main processors so that the wires kind of come out all in the right places. so that you don't, if you have some big interface like DDR or HDMI that has to cross over some other interface, then you're in big trouble because it's going to explode your board, right? You just can't do that unless you have 8 layers or more tech, and that costs a lot more money. So these things are kind of designed now to fit the board. And I guess one consequence of this is if you see that Pi 4 has the Ethernet connector on the opposite side to Pi 3, and that's because the only ways we could get the wires out, the RGMI interface to the PHY across here, was on this corner. And again, because you can't cross it over any other interface, it kind of had to be there, and then the connector had to be there. Otherwise, we'll end up, if you go to an 8-layer board, that's like a 20 to 25% cost up on the PCB, and the PCB is quite a big chunk of the overall product cost. So these are the sort of design decisions you end up having to make. But when Broadcom are designing the chips now, they're looking at we're looking at this. We kind of have a mock-up of what the board's going to look like, and we make sure we don't make mistakes like that.
James, we touched upon earlier on the compute modules. Now, there's been 3 compute modules with 4 with compute module 4. We had the original one, then we had the 3, then the B plus, didn't we? 3 B plus. The original ones were all set as a SODIMM form factor, but the new ones got this new, really dense layered dual connections. So I think it's 2 questions for this one, really. Why the change? But also, well, really, why do we need so much power in such a little board? Because Compute Module 4 is nothing. It's tiny.
Yeah, it's good, isn't it?
Yeah, it's good fun.
So, all right, let's deal with the kind of change from SODIMM. So we chose SODIMM because other people have used it for these kind of boards, and it does provide a nice single sort of point of connection between the board and the rest of the product circuit.
Yeah.
And it's kind of sprung as well, which kind of gives you a little bit of flexibility, and the sockets are pretty readily available. They are a little bit fragile. They're not super cheap, but also you're constrained in terms of how many IOs you've got. I guess the thing we learned with the compute module and CM3 and CM3 Plus was just that the simpler you could make it, the more stuff you could stuff on the module, the happier people were, right? So what they really wanted to do was take a module, wire their 5 volts to it, and it was effectively a Raspberry Pi, and then just bring out the connectors that they cared about. And meanwhile, we designed the original compute modules. This was before we had RF or wireless on the Raspberry Pi. So we learned a lot in doing the wireless. We learned how to modularize the wireless, and what that means is that if you buy a Raspberry Pi, say a 3B Plus or a 4 now, they are classed as a radio module in terms of the compliance side of it. So if you build one of those into a product, you don't have to go and do all of the hundreds of thousands of dollars of RF testing that you normally would. You can just say, well, this is just a radio module. Go see this paperwork over here. I'm kind of done, right? So we've really simplified building the Pis into products. So we built this little radio module that goes into the Pi 400, but also goes onto the TM4. So that kind of, people wanted wireless on compute modules, right? So that was an obvious one. And then it was really more just how much can we cram on that little kind of sort of form factor. And then after that, the sort of the layout was dictated again by where the signals come out. So it would have been very difficult to route the 2 connectors into the one kind of sodium connector. It would have made the board bigger and more, much more kind of complicated. So we'd always had the idea to do a different form factor like that, and it just, again, it's kind of like by experiment and by just mocking up the layouts, it kind of turned out to be, we can do this really nicely with that kind of 2 connector layout, and the wires come out nicely, and it's just 6-layer board. It's even uses slightly less tech than the Pi 4 itself, so it just sort of popped out very nicely. And kudos to Dominic who designed it. He did a great job of the layout. It's probably it's super dense. Like there's really, you couldn't get another wire across the board. It's very very packed in, but it's worked out just right, as these things often do, right? You sort of just get to the point where you're pushing things around and you're kind of going, oh, what should I do this or should I change this or whatever, and then after a little while of just mucking about with it and pushing it around, it sort of you get a gel, and it just sort of, it all comes together, and it's nice. I don't know. That's the best way I can describe it.
Speaking of the board, I'm just curious, have you guys ever considered a different color, or was it always, hey, we're going to make sure the PCB is green?
I think it's just the design sort of language now. Raspberry Pis are green. We have considered doing different colors, but it presents a bit of a hassle through manufacturing, because manufacturing is so automated and it's so like full bore, right? Enormous amounts of product go in one end and enormous amounts of product come out the other end, right? And you're building a Raspberry Pi that, one every 2 seconds. And it's kind of, there's quite a big cost to even changing the PCB color, right? Because you've got to stop all that machinery, load in a whole different set of PCB, build the product, and then, so there's kind of just that kind of effort. But I think we're just sort of thinking, well, maybe we will do it sometime in the future, but maybe we just haven't found the right awesome product to do it with. So it's James, a special we might keep in the bag.
I seem to remember the very early days of Pi. There were some coloured Pis. They were like,
okay, yeah, sorry, no, you are right. Actually, we did Brazil Pi, so we made that kind of a blue color Pi 3. There's Brazil Pi 3, and that was done to differentiate those kind of for compliance reasons, because you have different compliance in Brazil, and we were sort of seeing that people were importing non-compliant Pis, or they were exporting ones, because compliance only works in certain countries, and they're, we didn't really want them bleeding across into the wrong compliance country. So we did that, actually, yes. And those were made. Did we make them in? So we did actually make some in Brazil for a bit to see if we could do it in a kind of really cost-effective way to help get the price down in Brazil. I don't think in the end, it didn't really work out for complicated Brazilian sort of import tax reasons. But so we have done that. We have done a few prototypes in different colors, but largely we just stick with green because it's the Pi color, I think.
I have somewhat of a loaded question. Well, it's because it's about something there's a lot of uncertainties around, so to an extent I understand. Supply chain issues aside, I want to talk about the Raspberry Pi Pico microcontrollers. Do you see any potential future developments for Raspberry Pi microcontrollers in any capacity?
Yes, I think so. Definitely. We have a chip team, right? So what are you going to do with a chip team if you've got a chip team? You're going to make some more chips, I think. We're not going to fire them. They're really good guys. You'll see some more stuff in microcontrollers. I mean, probably not for a while. We've done a lot of work to bring Pico and RP2040 into proper mass production. It takes a surprising amount of work to get a chip like that into volume production if you want to make upwards of hundreds of thousands a month to millions. So we're building something that can scale to millions of units a month. And what they call the back end of it is quite. You've got to take your silicon wafer, saw it up, stick it in the little plastic package. You've got to bond it out. You've got to then encapsulate it, saw it out, test it, and then package it in a reel, ship it. So the whole test thing is an interesting one. We for a long time we were first of all we were just constrained by getting the volume through. Then we're constrained by tests, right? So getting these units pushed into a tester, fully automated, and then out, and then reeled up. So we had some bottlenecks there, but we've actually kind of brought up a site, like Raspberry Pi often do. We just decided to do it ourselves. So we've got a site now that has test gear. It can take in chips and run kind of like almost unsupervised for large chunks of time, just churning out many hundreds of thousands of chips every week. So we kind of put that together. So that's working, and we're going to bring up another couple of sites as well for Pico as well. So we're right into this curve now where we have silicon sort of die and wafers, and we've now got the packaging side resolved.
Yeah.
And the yield's good, and it's sort of like starting to get into the steady state now. So, hence you probably saw that we've launched Raspberry Pi Direct yesterday.
Yeah, we covered that yesterday. Yeah.
Yes.
Exciting thing for us. So we're going to see how that goes. What we want to do is make it really easy for people to buy these microcontrollers. And I know people are struggling to get other microcontrollers. So why not give
True.
people?
You said before 2 Pico sites. So can you elaborate on that a little bit? What do you mean by 2 Pico sites?
Okay. Well, we do actually have 2 Pico sites, but we've also, did I say Pico? I meant RP2040.
Right.
So normally what happens is once a chip's in mass production, there are, so TSMC or whoever's your fab will make your wafers and they'll ship them to a test and packaging company. And we've got 2 test and packaging companies that we're bringing up. And normally you'd site all your test hardware with those guys, right? They'd have the tester, they'd look after it, they'd test, they'd package the silicon into the little chip, and then they'd also test it, and then they put it on the reel and ship it for you. So we're not quite there yet. They build the chips, but then they ship the chips to our test site. We then test them and then ship them to Scotland to be reeled, because it turns out reel service in Scotland are pretty awesome and do a fantastic job. And then we ship them out. But eventually we'll transition to the standard model, if you like. But that's just takes quite a long time. Once we had working silicon, we wanted to ramp it really quickly, and this is how we've done it. We've kind of got our own site. And that site will probably, once we get the 2 big guys up and running, that site, even though it can do high volume, it'll ramp down, and then we'll use it for test development of the next chip. So it's another one of these. We like doing things ourselves. We like we learn a hell of a lot doing this. And I mean, a lot of us come from chip background, so most of the engineering team have come from companies where we've designed chips. I was part of the team that did 2835 and the V3D back in Broadcom. But that whole picture, doing the whole back end thing, in Broadcom and the big semi companies, there's just a team that does that. So it's been a good learning curve for us to bring up real production of a real chip, and it's been fun.
So Martin asks, what about hardware Easter eggs like the hidden logo in the silicon of the RP2040?
Well, so I don't know. Well, you probably spotted 02. If I don't know if you've seen the X-rays of the 02W product.
Yes.
You've seen Simon's put the little Raspberry logo in the BGA ball out. That's kind of cool. I'm just going to disappoint you and say there's nothing particularly exciting in Pi 4. I did put my initials underneath the Ethernet in the USB connector because I like put initials on boards and little logos and things just for fun. But yeah, sorry, nothing too exciting on the Pi 4. But yeah, we've got logos on the chip, and I think if you follow some of the chip decap guys on Twitter, there you'll see lots of fun. Like I think one of the chips that I saw recently, literally they put the design team's faces in the silicon, right? So you could if you got your microscope, you could go look at nice little pictures of the guys who designed the chip. That was pretty cool.
Mark and Russell have a couple of comments. You're going to have to bring one of those up, Abram. The people want to know about getting Wi-Fi on a Pico or something like a Pico-sized microcontroller.
It's something we're certainly thinking about. I can't tell you any more than that. It's an obvious,
Come on, James.
obvious thing that people are going to want, right?
Just say it. Pico 2 with
table.
Wi-Fi. We want it.
Well, anything with Wi-Fi takes ages. Is all I'm going to say, right? It takes even a long time to decide if you can do something. And of course, guys like ESP have an advantage as they actually have a die with Wi-Fi on it, right? So
yeah.
I can't say we've got an answer, but it's not. It's definitely an interesting thing, and for sure, we're going to look at it.
Yeah, I mean, for for the folks in the audience, though, I mean, we probably know this, but there are ways of doing it. So, here's the
absolutely.
Here's the Arduino RP2040 Connect.
There are RP2040 boards with modules on, and there are Wi-Fi modules you can go buy, and I think that's great.
So
I think we're a bit of a long way away from an integrated chip with Wi-Fi, I'm afraid, but never say never.
So I'm curious, how you said it takes several years. How far ahead do you start planning, and do you plan more than one revision at a time? Like, were you working on the Pi 4 when you were working on the 3? I mean, how far ahead do you guys plan, and how long does it take?
So increasingly longer and longer, right? I mean, as we build these new products, each product's got to be better than the last one, and we always try and keep the price the same. So that sort of necessitates more complicated technology, right? Faster processors, and to some degree, you're also waiting for the silicon cost to come down. But to kick off a sort of a design plan with someone like Broadcom for making a chip, and we also get our power silicon kind of semi-custom as well. These things are years in the making, right? They're big, complicated things, and even though they're somewhat evolutionary, there's still a huge amount of work to do to get one of those things running. So I think we launched Pi 4 in mid 2019. It was at least 4 years from the beginning of the discussion about, hey, we should do this, and what are we going to do? But for sure, it's then we have the kind of managing the chip design stuff, while that comes before the board and the form factor, the final form factor kind of decisions. And yeah, that's only got worse, right? So in terms of the amount of work required to do the next one, right? So it's it takes longer and longer. But then again, Pi 4 is a great product. We see that's going to be around for a long time, and I'm sure Pi 5 when it arrives will be great, but don't hold your breath for it anytime soon.
I want to touch again on third-party products, because you've designed so many. Raspberry Pi, well, Raspberry Pis, what is your favorite third-party board? It could be a hat, it could be a carrier board, it could even be something that uses RP2040, and you can list a couple if you want.
Wow, my favorite ones. I mean, I find it hard to pick favorites. I mean, am I allowed to pick Raspberry Pi products?
No, that's cheating. It's third party.
No, funny, I know. I think the PIM guys do some nice things, and it was nice to see them come out with a whole bunch of Pico things. And you know, I like actually one of the things I really like is the kind of unicorn hat. I know we have the Sense hat, and I do like that as well. But I like the sort of high density LED hats and hats with nice displays on. Right, of course you can buy the Raspberry Pi display. A hat with a cool high density display is also very cool. So that you know, what am I going to get my daughter programming when she finally, you know, she is at school, but I'm kind of, you know, giving her one more year to get her maths under her belt, and then we'll start doing it. It's going to be the visual stuff, right? That we're going to start with, right? Making LEDs light up and making patterns and things. So I do like those. What other hats? Oh, that's a tough one. Because of course there's so many now as well. Yeah, I don't know actually. Do you guys I mean, can I change I'll turn the question around. Do you have a favorite one? Is any particularly that stand out? Hey, there we go. Explorer hat.
Explorer hat Pro.
Yeah.
Absolute classic.
The Pro. Yeah.
Absolute classic. I've done so many lessons and so many projects with this. It's unbelievable. And for like 20 quid, it's a no-brainer. Yeah.
I mean, in general, I like the ones that are, apart from flashy lights, because that just gets me every time. Ones that have lots of functionality and are cheap, so that people can just pick them up. I mean, that's great. I mean, I've forgotten about Explorer, but that is a really good one as well. Maybe just plugging PIM here.
Basically, yeah. If you look at my desk and what's behind me, it's pretty much Pimmeroni stuff.
Yeah, but they make lovely stuff. There we are, unicorn hat. Yeah.
Very nice.
I would say the Picade probably, because it gets the most use out of all of the Raspberry Pi add-ons that I've bought.
Yeah.
I mean, I wouldn't get the most use for me, but I think I really like the innovation in the Braincraft hat from Adafruit. So I thought I think that is pretty cool. So we have time for one more question from Les.
Right. Well, this is a two-part question. I'm becoming like some sort of politician now, aren't I? Sorry. So everyone's going to want to know about Raspberry Pi 5. When's coming out? What can we expect? So I'm going to guess your answer is going to be, we don't know yet. I can't tell you anything for that one.
So, well, I can say we didn't really know, and it's become even less clear with the whole semiconductor shortage thing. But yeah, pretty much that, I'm afraid.
So I'm guessing it's going to delay the Raspberry Pi 5 coming out, the semiconductor shortage.
It's sort of, I mean, it's hard to transition a product when you've got lead times of 2 years on things, right? I mean, because you've got to figure out how you're going to drain out your pipelines of some of the previous products and ramp the new one. So actually, irrespective of when it was coming, we wouldn't, be launching it just because of that kind of like technical supply chain thing is really difficult. And of course, with all of these products, it's the same with any upcoming Pi now. They're built on a lot of custom silicon. You've got to have all those silicon chips designed. They've all got to work. They've then all got to work together. Then we've got to write all the software. And then we've got to, test it to death, and it just takes a long time. So, be assured that we are working on Pi 5 and indeed Pi 6, right? But they are long kind of gestation. There's a lot to do for those kind of products, and I mean, it's also, conceivable that they change with time, right? If we find a bug and we need to work around it, or we find a better solution, or the cost doesn't work, it's in some ways, it's always a surprise when we get to launch a product, because it's like the stars have aligned, it's all working, the cost structure works, and bang, we can do it. Right now, because of supply chain issues, cost structure and supply chain things just aren't going to work for anything. In fact, it was weird that it was great to be able to launch a product like 02W, and that we could launch that because we actually had a bunch of stock because we pre-pipelined a lot of stuff. But any other big pies, there's just no hope for the moment. It's keeping the wheels on and trying to get as much supply for the existing products.
Yeah.
Yeah.
Well, flipping it around again. So, what would you like to see on Raspberry Pi 5? What feature would you like?
Yeah, I mean, if we launch a Pi 5, it's going to be faster and quite similar.
Yeah.
I would imagine, without being able to tell you everything, because again, it can change. As I said before, PCI Express is a nice interface. It would be nice to work that onto a board. But again, it sort of depends on cost, right? What would you do? M.2 is an obvious one, but it has power issues. It's a big connector. Relatively, it's how do you mount the things? You look at other products with those ports on, and it sort of work, but then the big long M.2s are huge. So there's a whole bunch of practicalities around that, but I think probably PCI Express is my one that I'd really like, because I think it just enables a whole bunch of other stuff, right?
Very true. And talking about M.2, so Pioneer from Diodes Delight.
Yeah.
Has M.2.
Timon, he's done a nice job of that, hasn't he?
Excellent board, really good fun to play with.
So yeah, so people can grab one of those, grab a Compute Module 4, and so you can have it today. It's just not exactly in the Pi form factor.
Yeah, that's great. Well, I wanted to thank James for coming on and showing us his prototypes and answering all these questions, and of course for being behind some of our absolutely favorite products. So thank you so much for joining us. It was an honor and a privilege. Thanks to all of you for listening and watching. We will be back again next Tuesday at 7:30 p.m. UK time, 2:30 p.m. Eastern, with Alan O'Donohoe of Raspberry Jams, and we will see you all next week. Bye, everyone.
Pleasure, guys. Thanks very much. Thanks for having me.